Okay, students. So here I have 5 different types of thermometers that we use to measure the temperature, either in the laboratory or for our day-to-day purposes or in the field of medicine. So first I have the glass mercury thermometer. So here you can see normally it is kept inside this cover for protection. So this is the glass mercury thermometer. You can see here at the bottom the bulb containing mercury. You all know mercury is a liquid metal and it shows uniform expansion with heat. So then we can read the temperature there. So then this is the bulb, the glass this is the bulb, and then here is the glass tube which is calibrated. Here you can see the temperature scale starting from minus 10 degrees Celsius and goes on up to 110 degrees Celsius. So that is the range of temperature that can be measured using the glass mercury thermometer. So you should be able to identify the bulb that contains mercury, then the glass tube that is calibrated, and inside, students, if you look closely, you can see there is a capillary tube. So the mercury rises up along that thin capillary tube. So there is uniform expansion and uniform scaling is possible. But when we try to read the temperature, we will have to rotate it around so that you can see the mercury column as a broader column. We have discussed that with light as well. Due to refraction, you see it as a broader column of mercury. So then I have the second type, that is the glass alcohol thermometer. So here that is again similar to the glass mercury thermometer. The same way there is the bulb here and the glass tube. Inside there is a capillary tube and the glass tube outside is calibrated so that you can get the temperature readings. But here, can you all see the difference? This is reddish in color. The reason is alcohol is a colorless liquid. So in order to observe the alcohol column, we need to color it. So it's colored in red color. So here again, you can see the temperature range starting from minus 10 degrees up to 110 degrees Celsius. So both the thermometers can be used for laboratory purposes. Glass mercury thermometer and glass alcohol thermometer. Then we have the modern one, that is the digital thermometer. So here again you can see this doesn't have mercury in it or the glass tube, and this is the point that is inserted into the object of which we need to get the temperature, or if usually we use this for clinical purposes where a person's temperature is read. So then again this is the part that reads the temperature, and here on this display you can observe the value. You just need to turn on the button, and then when you come in contact with a hot object you can see the temperature reading increasing. So here students, you can see at the display this part we can read the temperature of a person. When it is in contact with a person, you can get the temperature reading. So this is very easy to handle and usually used for clinical purposes. The same purpose we have been using the clinical thermometer. Now this is the digital clinical one. This is the normal mercury clinical thermometer that also has the same purpose, but only thing is here again inside the bulb there is the mercury, and like the normal mercury thermometer, here the mercury column rises up when in contact with a hot object or the temperature of a person is read, then you can get the temperature reading. But here again students, when you look at this carefully, this is the calibration given there. So inside there is a capillary tube. If you observe this part closely, you can see there is a small curve in the capillary tube. The reason is when the thermometer is placed to a person, it's in contact with a person, the mercury column rises up, but we need time to read the temperature. So until then, the mercury column should not go down. To prevent that only, there is a small curve there. But when you move it like this or shake the thermometer, the mercury column goes down. So before taking the temperature, they usually shake it so that the mercury column goes down. Then you read the temperature. You can take it away from the person. You can observe the temperature clearly. Until then, the mercury column will not go down. So you can observe all those in this clinical thermometer. So then, another thermometer that you all are familiar with. All these 4 types, they have to be in contact with the person or the object in order to read the temperature. But here I have the most modern one where we read the temperature without being in contact with the person. So this is a non-contact IR thermometer. IR means you all know infrared thermometer. So here this is the part that receives the infrared radiation from the person, and here the temperature reading will be displayed. You need to turn on, and also here you can see when we press the button on this side, you can get the reading. Now I am just reading the environment temperature, but if you hold it near the forehead of a person or the hand of a person, you don't have to contact the person. You just hold it near the person, you can get the temperature reading. So this is a non-contact infrared thermometer. So I'm sure you are familiar with all these types. Out of those, the first 2, glass mercury thermometer and the glass alcohol thermometer, they are used for laboratory purposes. Then the 2 types of clinical thermometers, one is the mercury one, the other one is the digital one. Both are used for medical purposes, and even the third one, that is also to get the temperature of people. Again, the clinical use. So those are the different types of thermometers that you need to know about. Okay, students. So now we are going to observe what happens when you put a very hot object into room temperature water. So to do that activity, I have a small volume of water inside the beaker that is at room temperature. First we need to take the temperature reading. So here, if you place the thermometer, you all know students, you should not touch the beaker. It has to be completely immersed in water. And here, can you see the temperature reading? It is 22 degrees Celsius. So that is the room temperature of water. So after that, I have this piece of steel. So what I'll be doing is holding it with the pair of tongues, I will heat it in the Bunsen burner, and once it becomes very hot, we will put it into water. And in order to mix the water completely, we need a stirrer there. So I have that as well. I will place the stirrer inside water. So once I heat the piece of steel, I will put it into water, and then we will observe what happens to the temperature of water. So here students, we will have to heat this piece of steel. I'll heat it for some time. If we hold it to the blue flame, you know the temperature is higher, so it will become hot more faster. Now I will insert this into the water. You shouldn't drop it all of a sudden. Now I will put it in, and at the same time we can use the stirrer to mix the solution, and also I will get the temperature reading. Can you all see the thermometer rising? The reading increasing in the thermometer. We will have to stir also so that the heat is distributed evenly. At the same time, observe the temperature reading. So still it is at 26 degrees Celsius. So you have to observe, students, the temperature reading is at a certain value now. It is 26 degrees Celsius. So what happened there? The heat that was absorbed from the flame by the piece of steel was given to water. So initially water was at 22 degrees Celsius. Now it has come to 26 degrees Celsius. After this point, the temperature remains constant. And there we say the system has obtained thermal equilibrium. So since the temperature is remaining at 26 degrees Celsius, you can see that there is thermal equilibrium. After that, there will be heat loss to the environment. Then you can see the temperature decreasing. So can you all see, students? Now the temperature has decreased to 25 degrees Celsius. So from this observation, can you all understand what happened? As I explained before, first the room temperature of water was 22 degrees. It was anyway somewhat cool, but still it was 22 degrees. But then I heated the piece of steel, put it into water, and then you were able to see that the temperature increased up to 26 degrees Celsius. So the reason was the heat that was present in the piece of steel was given to water. And afterwards, there was equilibrium reached. That is why the temperature remained at 26 degrees Celsius for some time. And at that point, I said it is the thermal equilibrium. Thereafter, temperature from this whole system, that is water, the steel object as well as the container, the heat is lost to the environment. So that is why the temperature starts decreasing again. So I am sure you can understand that heat is transferred from one object to another and there can be thermal equilibrium reached. Okay, students. So now we are going to do this activity in order to understand the heat capacity of different substances. So to understand that, I have 3 different beakers. In this first one, I have 40 centimeter cubes of water, and in the second one, I have 40 centimeter cubes of coconut oil. So they have the same volume but different materials. And in the third one, I have water again. So the first and second beakers have the same material but they have different volumes. The first one is 40 centimeter cubes and the second beaker with water contains 80 centimeter cubes of water. So double the volume. This is what we are going to do. Now I have already set the stand with the thermometer so that we can easily read the temperature when we heat the liquid. So first I will be placing the water on this stand, and then with the Bunsen burner you all can also use a candle, and normally when we do this activity it would be more better, you will get better results if you can have 3 Bunsen burners or 3 candles, identical candles burning at the same time, so that you provide the same circumstances for all the 3 activities. But here I am going to do it one after the other. But the thing is, we will use the same time interval. So if I take, let's say, 5 minutes to heat the 40 centimeter cubes of water, we will need to take the initial temperature and the final temperature. The same way with coconut oil and 80 centimeter cubes of water. So let's start the activity now. Okay, students. So I have placed the beaker containing 40 centimeter cubes of water. Can you all read the temperature there? The initial temperature? It's 23 degrees Celsius. So that is the initial temperature of water. So while I start the burner, I will also start the stopwatch. So we will observe after each minute, we will see how the temperature changes. Like that, we will try to do it for at least 3 to 5 minutes. So students, while I place the beaker over the Bunsen burner, I will start the stopwatch. So you all know normally in school we do it as a group. So one person can place the beaker there. At the same time you all can start the stopwatch, and also as you do that, you have to also place the thermometer into the water. So here I am going to move it somewhere close. At the same time, I am starting the stopwatch. We will have to time it and observe the temperature every 1 minute. So can you all see, initially the room temperature, it was 23 degrees Celsius. So I have a place to mark the values as well. 23 degrees was the initial temperature. Now you can see the thermometer reading, students. It's about 34 degrees Celsius. Can you all see? So that's after 1 minute, it is 34 degrees Celsius. So we will leave it for another minute and see how the temperature increases. Can see it's 1.5 minutes now. We have another 15 seconds to get to 2 minutes. You all can look at the thermometer, students. It's about 43 degrees Celsius now. So at the end of 2 minutes, it is 44 degrees Celsius. So I'm recording the temperatures here. We will leave it for another 1 minute. Still you can see the temperature reading increasing. After another 5 seconds time, we will read the temperature again. Now you can see at the end of 3 minutes, the temperature is about 55 degrees Celsius. So here that is 55 degrees Celsius. So with that, I will stop the activity with 40 centimeter cubes of water. We will repeat the same thing with 40 centimeter cubes of oil now. Okay, students. So now the second one, that is the coconut oil, 40 centimeter cubes of coconut oil. I will get the temperature reading first. So here you can observe the initial reading. Can you all see the reading, students? It's 24 degrees Celsius. So then, as we did before, we will place it on the stand, and while I bring it to the flame, I will on the stopwatch so we can time it. So initially, I will have to place the thermometer as well. So here, students, since we have different values for the initial temperature, we will see how the temperature increased with time. Then you can compare the heat capacities of the liquids. So we have in another 10 seconds, students, we will have to get the temperature reading. You can see it's rising faster than before. Now it's almost 1 minute. You can see the temperature reading. It's about 47 degrees Celsius. So I will note. So you can see here the values are different. So we'll have to wait for another 1 minute. Now at the end of the 2 minutes, you can see the temperature reading is 66 degrees Celsius. So in another 5 seconds, we need to observe. So after 3 minutes, students, you can see the temperature reading is about 79 degrees Celsius. So now can you all compare and see how the values have changed? I will remove the thermometer and also take the oil away from the burner. So from the readings, can you all see, students, the readings here? We took equal volumes of water and oil. You can see compared to water, the oil became hot, the temperature increased faster. So that means the heat capacity of oil is less compared to water. That is why it becomes hot faster. Then what are we going to compare? We are going to use the same liquid water but with different volumes. So now students, we are going to use water, two different volumes. So the same liquid, when the volumes are different, we'll see how the heat capacity affects the increase in temperature. So as I did before, first we need to take the initial temperature. So to do that, I will hold the beaker with water and I make sure that the thermometer does not touch the beaker. You have to immerse the thermometer in completely and get the reading. Can you all see the temperature reading, students? The initial temperature is 23 degrees Celsius. So like before, we have the same initial temperature, 23 degrees Celsius. So now, as I place the beaker over the Bunsen frame, again I will start the stopwatch and also there's immediately I will insert the thermometer in. So here you can see, and we will place the thermometer. So after 1 minute, we will get the temperature reading. So now students, you can see the temperature is 26 degrees Celsius. So after 1 minute, only a small increase can be seen. We'll wait for another 1 minute. In another 5 seconds, we will get the second reading. You can see, students, it's 29 degrees Celsius. So after 2 minutes, it's 29 degrees Celsius. We'll wait for another 1 minute. Again in another few seconds. Okay, so this is after 3 minutes. You can see the temperature has risen to 34 degrees Celsius. So with that, we have got all the readings. Now I will remove the thermometer and also we can off the burner. Okay, students. So, did you all get the proper observation of this activity? We use 40 centimeter cubes or 40 milliliters of water, then 40 milliliters of oil and again 80 milliliters of water, 80 milliliters or 80 centimeter cubes. So, initially, the initial temperature of water was 23 degrees and then you can see when we heated the water, after every minute we were able to observe the temperature rise and the maximum temperature was 55 degrees Celsius after 3 minutes. Compare that with the value of oil. That is for 40 centimeter cubes of oil. If we calculate the difference, here it is from 23 degrees, this became 55 degrees Celsius. So, the difference was 32 degrees Celsius within 3 minutes. If you look at the oil, you can see it went up to 79 degrees Celsius but started with 24 degrees Celsius. So, there was a difference of 55 degrees Celsius within 3 minutes. And the last one, we had double the volume of water. So, there you can remember the initial temperature 23 degrees Celsius. It only went up to 34 degrees Celsius. So, the change was observed as only 11 degrees Celsius. So, these are the values that you need to understand. Compare the same volume of water and oil. Oil became hotter more quickly. Within the 3 minutes, the temperature increased more. So, that means the heat capacity of oil is less. So, that is why it becomes hot faster. Whereas the heat capacity of water is compared to oil, it is higher. So that's why the temperature increase is less. It's only 32 degrees Celsius. But when you compare the two different volumes, when we took double the volume of water, the increase in temperature was less. So that is what we need to understand here. So students, if we had 3 Bunsen burners simultaneously, you would have got better exact results, but here we saw that there was a slight difference in the initial temperature of coconut oil, but still we were able to get the difference in temperature after heating for 3 minutes. So from that you all can understand the difference between the heat capacity of different liquids and how the volume affects the change in temperature. Okay students. So this is an activity where we use thermal expansion and contraction in our day-to-day life. So I'm sure you might have this experience where two glasses get stuck together. Like say we wash the glasses, we place it one inside the other and then leave it aside for a few days. And when you come back and try to take it apart, they don't come off. So the reason is the two glasses are stuck together. If we try to break it out or pull it with a force, then there is a possibility that the glass can break. So what do you do then? We use thermal expansion. To do that, what we do is into one container, we take warm water. You can see it's warm water. And into the other, we need to put ice or ice water. It can be ice or ice water. So what I'll be doing is I will put ice into the top glass so that it will contract due to the decrease in temperature, as well as place the bottom beaker inside warm water so that it will expand a little bit. Then easily we can take these two glasses apart. So into the first top one, it is ice and ice water together, and I place the other glass into the water. Now if I leave it for some time, I can pour more water also. So now if I try to take it apart, then it will be easier to pull. Now here you can see the glass comes off easily. So what is the reason there? The glass that was kept inside warm water expanded, and the glass into which we added cool water with ice, it contracted. So there was a difference in the diameters. We were able to separate the glasses easily. Okay students. So now we are going to do this activity in order to observe the expansion of solids, that is thermal expansion of solids. When solid is exposed to heat or if you provide heat energy, the solids expand. To observe that, I have this ring, the steel ring with a handle here, and also attached to it is a steel ball, a metal ball. So now if I first insert the steel ball through the ring, you can see it easily goes through the ring. So that means the metal ball is smaller than the loop here or the ring here. After that, what I am going to do is I am going to heat the steel ball, this metal ball, and then we will try to insert it through the loop and observe what will happen. So now we will heat the metal ball. Now I will try and see whether it goes through. Still it's going through. Again we will try and see. Still it can go through the ring. We will have to heat it for some time so that there is enough expansion in the metal ball. Now again I will try it and see. Now you can see students, the metal ball does not go through the ring. So again if I cool this metal ball? Can you all see? Now it's not going through. Earlier it went through very easily. Now what I will do is I will cool it again. Now we will put it into water. So now the metal ball is cool. Again, if I try to put it through, can you see? It can go through the ring easily. So here from the two observations, initially you saw that the metal ball went in through the ring easily, so that the ring was larger than the metal ball. But once we heated the metal ball, it expanded and the diameter of it increased so that it could not go through the ring. Afterwards, I cooled it down. I put it into water, the metal ball cooled down and it contracted. So because of that, the diameter of the metal ball decreased and it was able to go through the ring. So from the two observations, you can easily understand the thermal expansion and contraction of solids. Okay, students. So in this activity, we are going to observe how two different metals expand on heating. That is, the heat expansion of metals differ, and therefore that can be used in the bimetallic strips. So here you can see, students, this is a bimetallic strip, two different metals riveted together. On this side we have brass and on this side there is aluminium. So from the color, the difference in the metals, you can identify the two metals and you can see they are riveted together. So it's like just one metal plate. And if I place it along this line, you can see it's almost a straight line. There is no curving of the bimetallic strip. But on heating this, you can see what happens. So I will hold it to the Bunsen flame and make it become hotter, so that there will be expansion to the metallic plate, but that expansion will be in a certain manner. Here while I heat it, students, you all can observe a slight bend, a curving of the bimetallic plate. That's because one metal expands more, the other one expands less. The one that expands more, it curves outwards. Now if we keep it along this line, can you see the difference? Now on the outer side towards your side, it is the aluminium plate and the brass is towards my side and the bimetallic plate has curved outwards. So that means aluminium expands more. So I will still heat it some more. Now if we place it along the line, can you see the difference? Earlier it was straight along the line, almost straight, but now you can see the side that is curved towards me is the aluminium plate, so that has expanded more. So that has higher heat expansion compared to the brass on your side. So now can you all understand the difference, students? And this is the bimetallic plate that is used in certain electric equipments where there is generation of heat. In order to control the temperature, they use these bimetallic plates. Okay, students. So now we are going to do this activity in order to observe how liquids expand on heating. So thermal expansion of liquids. So for that, I have prepared the setup here. You can see there's a beaker containing water. Inside that, you can see the test tube with colored water, and there is a cork attached to the mouth of the test tube, and into the cork there is a tube inserted. You all know the reason why we use colored water, so that it will be very easy to observe the change in liquid level. And in addition to that, as you can see here, students, I have attached a pointer to the setup, so you can see the initial level of the liquid. So then on heating, you will be able to see whether the liquid level rises up or goes down, or whether both happen, and whatever the changes that can be observed very clearly. So with that, I will light the burner, then you can see what happens in this activity. Okay students, now that the heat is being supplied, observe what happens to the water level inside the tube. So observe the tube students. You will see a slight decrease in the water level inside the tube. Can you observe that? The level has decreased a little bit. So a slight decrease will be there. After that, observe. Now you all can see the increase in water level inside the tube. So what happens there, students? Initially, when the water inside the beaker becomes hot, the heat is transferred to the test tube, and first the glass test tube expands. Because of that, water level decreases inside the tube here. Thereafter, the increase or the expansion of glass stops, and after that, the colored water inside the test tube starts expanding. That is why you see the increase in water level now. So can you all observe the expansion of liquids due to heat? That is thermal expansion of liquid or thermal expansion of water. You can see clearly the rise in water level inside the tube. Okay students, so now I am going to do this activity to demonstrate the expansion of gases with heat. So for that, I have a glass bottle to which I'll be fixing this balloon, and inside this beaker there is ice, and I have this glass container into which I'll be pouring some hot water. So first what we need to do is we need to place the glass bottle inside the So here I have kept it inside ice, and I will rub a balloon over the mouth of the bottle, and if we let it for some time like this, you will see that the rubber balloon will shrink. That is because the air inside the glass bottle will contract due to the cool ice here, and because of that the volume decreases and the balloon will shrink. So while that is happening, I will take some hot water into this. So now students, first I will place this glass bottle inside warm water. Then you all observe what happens. I'll have to observe the balloon. Here students, you all can observe the balloon. It's getting inflated little by little. It takes a little time, but still you can observe. You can see the inflation in the balloon. I will add a little bit more water. So now you can see it more better. Although it's taking time, it will inflate. So why does this happen? When we place it in hot water, the glass bottle gets the heat, and from there the heat is transferred to the air inside the glass bottle. Due to the heat, the air inside the glass bottle expands. And when that expands, it comes up and fills up the balloon. So that is why the balloon inflates. So now still you can see, students, little by little the balloon is getting inflated. Okay, students, can you all see it becoming more inflated now? When compared to the previous stage, the balloon has inflated to a certain extent. So now here you can see, students, the balloon has inflated nicely. So that is because of the expansion of air inside the glass bottle. Now if we take this glass bottle and place it again inside the ice, you can see the contraction of the balloon. Now see, immediately it has gone down. And again, you can observe the contraction. So on cooling, air contracts, and on heating, air expands. So can you all observe the contraction, students? It's very clearly visible now. So here you can see this is again a reversible process. On heating, air expands, and on cooling, it contracts. Same goes for the other states as well. So, okay, students. So, initially when we placed the bottle inside ice, the balloon was shrunk. After that, when I transferred it into hot water, the bottle was kept inside hot water. Because of that, the air expands. And then you were able to observe the inflation of the balloon. Again, now I have placed it back in ice. You can see the contraction of the balloon. So, from that you can clearly understand, due to heat, air expands on heating as well as it contracts on cooling. Okay, students. So, now we are going to observe the expansion of gases. We already did one activity with the balloon and you were able to observe the expansion of it, inflation of the balloon. Now here we have another activity where we use a coin, a glass bottle and hot water to observe the expansion of gases due to increase in temperature. So to do that, students, now I have a coin here. You all know in the coin there are these patterns, or the value of the coin and everything is marked there. So because of that, if I place the coin on top of the bottle here, on the mouth of the bottle, it has to be the same size so that air does not leak out. But what will happen is, because of those markings there is a possibility that air can leak out. To avoid that, what we will do is, I will place this coin in water. So those gaps will be filled with water. Then I will place it on this bottle. After that, I am going to place the bottle inside the beaker. And then I will pour some hot water. You all have to observe what happens. Right. So I will pour the water in. You all have to observe what happens to the coin. I'm adding some more water. So students, you all can see that the coin is getting flipped up and down. So that's again when the air expands, it pushes the coin up. But what happens is when the air flows out, again the pressure decreases there, so the coin goes down. Again, when there is an expansion in gas, as you saw now, the coin is being pushed upwards. So that's due to the expansion of air. Okay, students. So now I'm going to do this activity to observe conduction of heat in solids. So for that, I have a metal rod here, a piece of metal there, and to that you can see the with wax I have attached 3 head pins. And here I have this piece of cardboard so that heat does not come to this side by convection through air. So to prevent convection, we have this piece of cardboard, and once I hold one end of this metal rod, a very thin rod there, you can see that their heat will get conducted, and due to convection, what will happen? The wax will melt. So you can see the observation of the pins falling down. So you can observe the conduction of heat clearly. So I am going to hold one end of the observe the pins carefully. This again will take some time, students. So now look at the first pin. Can you see it has gone down? Because, okay, now it has fallen off. So that's because the wax melted. And throughout the metal rod, you will see the conduction. Now observe the second pin. That is also the wax is melting. So now the second pin also has fallen down. If heat is given all together at once, then you won't get this observation, because in metals or this metal rod, the heat is conducted from one end to the other end. So that is why one by one the pins are falling down. Now observe the last pin. It does take time for the heat to conduct. So that is why it's taking longer for the third pin to fall off. Now you can see the last pin also fell off. So from these observations, students, as I told you, the cardboard prevents the convection of heat through air. So it's only conduction through this metal. So here at one end we supply the heat. It has to come along the metal. So you saw the first spin falling down, after some time the second one, then the third one. So that confirms that the heat is transferred or conducted through this metal from one end to the other. So that is the process of conduction of heat through solid. Okay, students. So now we are going to observe how convection occurs in liquids or especially water. So for that, here I have made a sachet using potassium permanganate. You know it has a purple color, that is the condis, and I have made small holes in that small sachet so that when I pour water and heat it, you can observe the movement of potassium permanganate easily. So to do that, I have water here at room temperature. I will pour it into the beaker. And then we will have to place the beaker so that the Bunsen burner flame is to the potassium permanganate sachet. So you will be able to see the movement clearly. So for this to happen, students, the water has to become hot. So we will need to wait for some time. So while we wait, if we discuss the process, you all know what happens. Heat is given to the beaker and to the water inside it. Water particles become hot and the hot particles tend to rise upwards, while the cool water particles move downwards. And that creates a circular movement of particles. Hot particles going up and the cool particles coming down or moving downwards, and that movement is known as the convection current, and the process by which heat is transferred within the liquid is known as convection. So now here you can see, students, from these sides the purple color rising up, and with that you will be able to observe the movement of convection current, the hot particles moving up and cool particles moving downwards. Can you all see the movement of color, students? So in this you will be able to observe the convection current clearly. So here, students, you all can observe the movement of the particles, the hot particles rising up and the cool particles coming down. With the purple color of potassium permanganate, it will be clearly visible to you all. So that is the convection process. You can observe it clearly. Can you all see the process taking place? I'm sure you can observe it clearly. And somewhere in the beaker this side, you all can see the particle movement. Can you see from this side? Okay, students. So with that observation, I'm sure you were able to understand what convection is and how convection takes place in liquids, and that is how heat is transmitted from one point to the other in liquids. Transfer of heat by convection.